So what exactly is fruit quality? Fruit quality can be described by 4 different attributes: color and appearance, flavor, texture, and nutritional value. Blueberry breeders are interested in texture, sugar content, and acid content because they indicate consumer preference in their subsequent purchases. Luckily, these are heritable traits. These traits can be easily measured using simple lab instruments that are very common in fruit breeding programs. In this video, the instruments used to gather fruit quality phenotypes will be demonstrated. These include a texture analyzer to measure fruit firmness and skin toughness, Autotitrator to measure fruit acidity, and refractometer to measure soluble solids. First, berries need to be made into a purified juice sample to analyze any kind of chemical traits. After reaching room temperature, a randomized sample of fresh berries is homogenized using this small blender. Not all blueberries ripen at the same time on a given bush, so it's very important to take a representative sample from several different containers when doing chemical trait analysis. Here's what the blended sample looks like. Before moving on, the homogenate needs to be centrifuged to separate seeds, pulp, and skins from the juice inside. So now the seeds, pulp, and skins have been separated from the juice. To prevent any pulp, seeds, and skins from remaining in the sample, the juice has to be filtered with a cheesecloth. The total juice volume is measured and stored in 15 milliliter tubes at -20 degrees Celsius. Now the juice is prepared for soluble solids and titratable acidity tests. A titration consists of taking 6 milliliters of centrifuged juice and adding it to 50 milliliters of deionized water and placing a pH probe in the solution. For this titration, 0.1 normal of sodium hydroxide is slowly added to the solution until an endpoint pH of 8.2 is reached. The amount of sodium hydroxide required to reach this endpoint pH of 8.2 is used in the calculation to determine titratable acidity. The predominant acid contained in blueberry fruit is citric acid, so total titratable acidity is expressed as % citric acid. Using a pocket refractometer shown here is a quick and easy way to estimate sugar content in a blueberry juice sample. The refractometer is designed to measure the degree of light refraction as a beam of light bends when passing through a solution. This is known as the refractive index and can estimate the amount of solutes dissolved. Sugar is the predominant soluble solid found in fruit juices among phenolic compounds, amino acids, and organic acids. In general, the higher degree of which light is refracted, the higher amount of soluble solids in the sample. The sugar concentration of an aqueous solution is expressed as degrees Brix. 300 microliters of juice is placed on the lens and a light is shown through the juice sample. Combining titratable acidity and soluble solids provides the sugar-acid ratio, an important factor in determining eating quality. This texture analyzer provides objective measurements of texture along with a texture profile. To measure fruit firmness, the Kramer-Shear test is used. This test correlates closely to what eating a handful of berries is like. A bulk, random sample of 50 to 51 grams of fresh berries is placed in a compression cell under shears that will compress the sample. Kramer-Shear not only provides information about fruit firmness, but is a composite measurement of shear, extrusion, and compression forces. It also is a good indicator of crispiness, something that is highly sought after by consumers. The maximum force or max load that is required for the shears to completely compress the berry sample is recorded. Soft berries usually have a relatively low maximum force reading. The berry matrix is ultimately extruded through the bottom of the compression cell. To measure skin strength, this probe is used to puncture the skin on both sides of the equator end. The berry is placed against a stationary hard surface with the probe traveling at a constant speed. This puncture test provides an objective measurement of what it feels like to bite down on a single berry. The probe senses the opposing force of the berry until the skin is penetrated, entering and exiting the berry. The maximum force or max load required to puncture the skin is measured and recorded. Blueberry skins suffer tears and thus create leakiness and mold, a negative post-harvest condition. Skin strength can designate cultivars that may withstand tough post-harvest handling without tearing or bruising. The hard work that goes into measuring these phenotypes can lead to better tasting cultivars suited for the commercial market. Thank you for watching.